Dear children, already we have covered polynomials part 1, polynomials part 2. So prepare very well, prepare notes very well. Now we are going to cover polynomials part 3. Methods to find zeros of quadratic polynomial. Methods to find zeros of quadratic polynomial. In earlier video, we used middle term splitting method to find zeros of the quadratic polynomial. So what method we have used? Factorization method. So if they give polynomial, we can split the middle term and we can factorize it. After that we can find x value. So we are finding in that way zeros of given quadratic polynomial. Now quadratic formula. If we are unable to split the middle term, then we go for quadratic formula to find the zeros of quadratic polynomial. So what is the formula, quadratic formula? X equal to minus b plus or minus root over b square minus 4ac by 2a. This formula. X equal to minus b plus or minus root over b square minus 4ac by 2a. If you take plus, you are getting 1 0. If you take minus, you are getting another 0. Next, another method, graph method. The points where the graph cuts the x-axis are the zeros. So if they ask to find the zeros by using graphical method, we have to plot the given polynomial. Then the given polynomial where it intersecting the x-axis, the given polynomial, the given curve. After plotting the curve, we will observe the curve. If it is intersecting the x-axis, there we are having 0 of the polynomial. Exercise 2.2, question number 2, first bit. Find a quadratic polynomial whose sum of zeros minus 1 by 4. Product of zeros 1. So in this question, what they are asking to find? They are asking to find quadratic polynomial. What did they give? They gave sum of zeros. That means alpha plus beta is given. Product of zeros also given. That means alpha into beta is given. So they are asking to find quadratic polynomial satisfying these two conditions. Sum of zeros minus 1 by 4, product of zeros 1. By satisfying these two, we need to find the quadratic polynomial. What did they give? I am writing that. Alpha plus beta equal to sum. Sum of zeros is given. Sum of zeros alpha plus beta equal to sum. So I am taking it as yes. Sum. I am taking it as yes. Alpha beta product. Product is given. So I am taking it as P. So what is the formula for quadratic polynomial? If you know the sum and if you know the product of zeros, this is the formula. So x square minus sx plus p. S refers to sum of zeros, p refers to product of zeros. So what is the formula? You have to remember it. X square minus sx plus p. So simply you can say x square minus of alpha plus beta into x plus alpha beta. That is also fine. So you can remember even this also, x square minus sx plus p. Now s is given in the question, minus 1 by 4. Sum of zeros, alpha plus beta is given, minus 1 by 4, alpha beta, that is product is given 1. So I am taking these values in the formula, x square minus sx plus p. Substitute in x square minus sx plus p. So x square minus of s value is minus 1 by 4. So taking in the bracket, minus of here minus 1 by 4 inside the bracket. Minus 1 by 4 times x plus p. P is given 1. So I am writing 1 here. So x square minus of minus 1 by 4 times x plus 1. This there implies this is equal to x square minus of minus. So you are getting plus 1 by 4 times x plus 1. So x square plus 1 by 4x plus 1. This is the polynomial. Required polynomial is this. So if I wanted to get here some integral form. I can multiply this with in the denominator you are having 4, right? So you can multiply all this polynomial with the 4. You will get 4x square plus 4 into 1 by 4. So 4 will be cancelled. You will get 1x plus 4 ones 4. See here, multiplying by 4 we are getting the same thing, right? 4x square plus x plus 4. Required quadratic polynomial 4x square plus x plus 4. What is the required quadratic polynomial? 4x square plus x plus 4. Why this formula works? So x square minus sx, x square minus sx plus p. Why that formula works? Suppose the zeros of quadratic polynomial are alpha and beta, then the factors of the polynomial are x minus alpha times x minus beta. Therefore, p of x equal to, so these are factors, right? X minus alpha is a factor of p of x. X minus beta is a factor of p of x. That means p of x can be written as p of x is equal to x minus alpha times x minus beta. If you multiply these two, what you are getting? You are getting, see here, after multiplication, x square minus beta x minus alpha x plus alpha beta. So x square, taking x common here, minus x taking common, minus taking common, x taking common. So x square minus of alpha plus beta times x plus alpha beta. So this is the formula. So in place of alpha plus beta, I took it as capital S. Alpha beta, I take it as capital P. So here p of x equal to x square minus of alpha plus beta times x plus alpha beta. This is the required quadratic polynomial. In this way we got the formula. Now exercise 2.2, question number 2, second bit. Find a quadratic polynomial whose sum of zeros root 2, product of zeros 1 by 3. Okay, here also given same thing, right? Sum of zeros is given, that means alpha plus beta is given, product of zeros alpha beta is given. So what is the formula to find quadratic polynomial? Can you see the formula? X square minus of alpha plus beta times x plus alpha beta. So alpha plus beta, I have taken it as capital S, alpha beta I have taken as capital P. So S is root 2 I have taken sum, root 2 I have taken, product P I have taken 1 by 3. So what is the polynomial, required polynomial? X square minus root 2x plus 1 by 3. X square minus root 2x plus 1 by 3. So we are getting the same thing. You can see alpha plus beta equal to S, alpha beta equal to P, x square minus sx plus P. This is the formula. So S is root 2, P is 1 by 3. So x square minus sx plus P. So x square minus root 2x plus 1 by 3. So in the denominator you are having 3. I want to convert it as integer. So multiply all this polynomial with this denominator 3. So 3x square minus 3 root 2x plus 3 into 1 by 3. Here you will get 1. See here, after multiplying, we are getting 3x square minus 3 root 2x plus 1. Required quadratic polynomial is 3x square minus 3 root 2x plus 1. Now exercise 2.2, question number 2, third bit. Find a quadratic polynomial whose sum of zeros 0, product of zeros root 5. Can you say the formula? X square minus of alpha plus beta times x plus alpha beta. That means x square minus sx plus p. What is s given here? X square minus 0x plus p is root 5, right? So x square minus 0 times x plus root 5. What you are getting? See here, formula I have written. S equal to 0, p equal to root 5. Substitute in x square minus sx plus p. So x square minus 0x plus root 5. So what you are getting? X square plus root 5 you are getting. 0 into x is 0. So this term becoming 0. So what are the terms left? X square root 5. These two terms left. So I am writing here x square plus root 5. Plus root 5 I am writing here. X square plus root 5. This is required quadratic polynomial. Therefore, the required quadratic polynomial is x square plus root 5. Now exercise 2.2, question number 2, fourth bit. Find a quadratic polynomial whose sum of zeros 1, product of zeros 1. Can you say? So x square minus alpha plus beta times x plus alpha beta. What is the formula? Can you say once again? X square minus of alpha plus beta times x plus alpha beta. Simply you can say x square minus sx plus p, where s is sum of zeros, where p is product of zeros. Formula written. So sum is given 1, product is given 1. So x square minus sx plus p, that is the formula. So in place of s taking 1, in place of p taking 1. So x square minus 1x plus 1. So x square minus x plus 1. This is required quadratic polynomial. X square minus x square minus x plus 1 is required quadratic polynomial. Now exercise 2.2, question number 2, fifth bit. Find a quadratic polynomial whose sum of zeros minus 1 by 4, product of zeros 1 by 4. So formula I have written here. Sum is given minus 1 by 4, product of zeros given 1 by 4. Formula written x square minus sx plus p. So x square minus of sum minus 1 by 4 written, product 1 by 4 written. This is equal to x square minus of minus, you are getting plus. So x square plus 1 by 4x plus 1 by 4. So in the denominator you are getting 4. If I want to remove that denominator 4, I have to multiply this with 4. So multiplied by 4, we are getting 4x square plus x plus 1. This is required quadratic polynomial. What is required quadratic polynomial? Can you say? 4x square plus x plus 1. This is required quadratic polynomial. Now exercise 2.2, question number 2, sixth bit. Find a quadratic polynomial whose sum of zeros 4, product of zeros 1. So alpha plus beta is equal to s taking, alpha beta is equal to p taking, x square minus sx plus p. This is required quadratic polynomial. So we are finding it. S equal to 4 is given, p product is given 1. So substitute into the formula x square minus sx plus p. We are getting x square minus 4x, here 1. So x square minus 4x plus 1. This is required quadratic polynomial. Now this is the question asked in Feb 17th 2026 question paper, 1 mark question, multiple choice question. A polynomial p of x which has sum of its zeros equal to their product. What did they give? Here one condition they give. So sum of zeros s is equal to product of zeros p. So in place of s and p, what you have to take? You have to take the same. So alpha plus beta equal to alpha beta, that is given. So x square minus sx plus p. So in place of p you take s. So x square minus sx plus s. In that way you should get. That means so s equal to p. In the given polynomial you can observe where s and p same. Here this is I should have, what is the formula actually? So x square minus you should have x square minus sx plus p. Here I am having minus s sx plus p. So here s2 p also 2, s2 p also 2. In the quadratic polynomial, in the formula you are having this minus. So you have to check. So here s is 2, p is 2. That means so you may get here 2 by 3. You may get here 2 by 3. After multiplying with 3, you got 3x square minus 2x plus 2. So this is the required quadratic polynomial. If you check the first one, so here you are not having minus. So this formula itself wrong. So here see s and p not equal. Here 2 you are having, here minus 3 you are having. So this is not the required one. So here s is 2, P is 2. S and P same. So this is the condition given, right? Sum of its zeros equal to their product. Alpha plus beta equal to product. That means S equal to P. So S is 2, P is 2. So this is our option. We have to select this option to get 1 mark. So next check D also. Here S is 3 but P is 2. Not equal. S according to given condition this is not suitable. That's why we have to choose option C. Solution once you can see. For a quadratic polynomial ax square plus bx plus c, this is standard form of quadratic polynomial. If the zeros are alpha and beta, alpha plus beta is equal to minus b by a, alpha beta equal to c by a. They gave alpha plus beta equal to alpha beta in the question. So alpha plus beta is equal to alpha beta. That means alpha plus beta is minus b by a. Alpha beta is c by a. So a getting cancelled. Minus b equal to c. So what is the condition here you are getting? Minus b equal to c. So minus b equal to c. C equal to minus b. So option C. In option C you can see this is a quadratic polynomial. In option C, this is the quadratic polynomial. A equal to 3. What is x coefficient? Minus 2. So b is minus 2. What is constant? Constant is 2. So minus b. Minus b is equal to minus of minus 2. So we got one condition, right? Minus b is equal to c. If sum of zeros equal to product of zeros, we got one condition. That is minus b equal to c. That is the condition we got. That's why we are finding minus b. So minus b is equal to minus of minus 2. Minus of minus 2 is 2. C equal to 2. So minus b is 2. C is also 2. That's why option C is correct. So if the zeros are alpha and beta, S equal to alpha plus beta, P is equal to alpha beta, then quadratic polynomial can be written as x square minus sx plus p. That means S equal to p. That means x square minus sx plus p. Sorry, in place of p we have taken yes, x square minus sx plus s. So x square, we are checking the options. Here 3x square minus 2x plus 2 we are having. If we divide this by 3, so x square minus 2 by 3x plus 2 by 3 we are getting. So s equal to 2 by 3 we got, p equal to 2 by 3 we got. So s equal to p, satisfying. In this with this polynomial we are satisfying this condition. That's why this is the polynomial we have selected. So many ways I have shown you. So you can follow any method and quickly you have to identify the option, because it's for multiple choice question, 1 mark only you are having. Now in Feb 17th 2026 case study question is given from this chapter. So we are going to cover the case study question. This is for 4 marks. Okay, so I will read the question. During a theatre drama, a backdrop of building arches was used. The shape of arch can be represented by the polynomial. So p of x equal to minus x square plus 2x plus 8. So here coefficient of x square you are having negative, right? So you are getting polynomial. If you draw the graph for this polynomial, you will get a parabola like this, open downward. That parabola opens downward, where x represents the length. This x represents the length on the stage level. Answer the following. Determine the height of the arch. So height of the arch we have to find. See here, arch given in theatre drama, like this you are having arches, right? So this is the one you are having. So here look, this is x-axis and this is y-axis we are considering, and this point, maximum point you are having here. See at 1, if x equal to 1, at x equal to 1 you are getting y. That y they have not given, we have to find. So at x equal to 1 you are getting y. That means you are getting this value, height you are getting, right? For x equal to 1 you are getting height. For x equal to 1 you are getting height. So here see, given thing we are taking, given polynomial p of x equal to minus x square plus 2x plus 8. What they are asking in second question, find the zeros of the polynomial. We need to find the zeros of the polynomial. Which points on the graph represents the zeros? So on the graph which points represents zeros, that we have to show. Find the span of arch on the stage floor. Span of the arch also we have to find. Next question, write the coordinates of the point where the curve intersects the y-axis. So given polynomial, we are doing the solution now. Given polynomial p of x equal to minus x square plus 2x plus 8, we will find step by step height of the arch. First we will find the height of the arch, and then zeros of the polynomial, and then span of the arch, and then intersection with the y-axis. All that we will find. So identifying coefficients. What is x square coefficient? Minus 1. What is x coefficient? 2. What is the constant? 8. We are comparing with standard form of quadratic polynomial. So a equal to minus 1, b equal to 2, c equal to 8. So a is minus 1. So a is minus 1, b is plus 2, so written 2, c is plus 8, written 8. Now vertex formula. So for a quadratic polynomial ax square plus bx plus c, vertex occurs at x equal to minus b by 2a. So at x equal to minus b by 2a, you will have maximum or minimum. Here in the graph they gave at x equal to 1. In the graph already we have seen the graph, right? In the earlier slides we had seen the graph. So what we have noticed there, maximum point, at maximum point what you are having, at x equal to 1 y. So x is 1, at minus b by 2a is equal to 1, that is already given. So you no need to write this formula. Without writing this formula, directly they gave 1. So at x equal to 1, if you write x equal to 1 in the given polynomial, in place of x, if you take 1, you are getting maximum height you are getting. So this is the formula. If they don't give x coordinate, you have to write this formula, x equal to minus b by 2a. There you will occur maximum or minimum. So in this polynomial, you will get maximum. So here you got x equal to 1. Even if you use the formula, so you are getting x equal to 1 only. They are already given this x equal to 1. So maximum height occurs at x equal to 1. How you got x equal to 1? X equal to minus b by 2a. So already we identified the coefficients. So we have written b value, a value. So 2 into 1 is 2. So 2 into minus 1 is minus 2. So minus 2 by minus 2. That means minus 2 by minus 2 gives 1. So maximum height occurs at x equal to 1. Substitute x equal to 1 in the polynomial. P of x equal to minus x square plus 2x plus 8. This is the given polynomial. In place of x, I am taking x equal to 1. So P of 1 equal to minus 1 square plus 2 times 1 plus 8. P of 1 equal to minus this 1 square. 1 square is 1. So minus 1 you are getting. 2 times 1, 2 you are getting. Plus 8 plus 8. So minus 1 plus 2 plus 8. After simplification, 8 plus 2, 10, 10 minus 1, 9. So P of 1 equal to 9. So what is the height? 9. What is the unit they gave in that unit you have to write? Feet. In feet they gave. So height of the arch is equal to 9 feet. First question is over. So height of the arch 9 feet. So at x equal to 1, just you have to substitute x equal to 1 in the given polynomial. Directly you are getting 9 feet. So 1 mark question, that is. Now finding the zeros. To find zeros, always we have to take p of x equal to 0. I told this many times. Remember it. So to find zeros, what we have to write? Always we have to write p of x equal to 0. So given polynomial we are writing in place of p of x minus x square plus 2x plus 8 equal to 0. Now both sides multiplying by minus 1 to eliminate this minus 1 coefficient to x square, we are multiplying with minus 1. So if you multiply all this with minus 1 times minus x square, you are getting x square, minus 1 times plus 2, you are getting minus 2, minus 1 times plus 8, you are getting minus 8. So x square minus 2x minus 8 equal to 0. This is the quadratic polynomial. I want to find zeros. So x square minus 2x minus 8 factorization. Factorization means I want to try to split the middle term. If I am able to split the middle term, I will split the middle term and find the zeros. So to split the middle term, I need to find two numbers whose product should be a into c and the sum should be equal to b, coefficient of x. Okay, what is x square coefficient? 1, that is a into c, constant is minus 8, c is minus 8, so a into c, that gives minus 8, product equal to minus 8, and sum should be this x coefficient minus 2, that is the sum. So sum should be minus 2. So I have to get two numbers now. I have to find two numbers. Those two numbers, what they have to satisfy? If we multiply those two numbers, that product should be minus 8. That product should be minus 8. If I add those two numbers, I should get minus 2. That is coefficient of x I should get. So what are the numbers satisfying these conditions? Numbers are minus 4 and 2. So minus 4 into 2, how much you are getting? Minus 8 you are getting. Minus 4 plus 2, if you add these two, minus 4 plus 2, sum, that is x coefficient minus 2 you are getting. Some x coefficient you are getting minus 2. So these are required two numbers satisfying whose product minus 8, whose sum minus 2. I am taking these two numbers to split the middle term. So in the middle term, so I will write x square as it is, minus 8 also as it is. Only middle term minus 2x I will write minus 2x. How I am going to write? Minus 4x plus 2x. Minus 4x plus 2x, how much? Minus 2x only. So in that way I am splitting the middle term. See here, x square minus 2x minus 8, this is given. So equal to, in place of minus 2x, what I am writing? All this I am writing, minus 4x plus 2x. This I am writing. So x square as it is written, minus 8. Minus 8 also as it is written. Only minus 2x, splitting the middle term. How I got split? Minus 4x plus 2x. In this way we have to split. Now grouping the terms and then taking common x, and we will find x values. So x square minus 4x plus 2x minus 8, taking x common, x times x minus 4. Here if you take x common in these two terms, so x times x minus 4 you are getting. If you take 2 common in these two terms, so 2 times x minus 4 you are getting. So x minus 4 you are having here, x minus 4 you are having here. So x minus 4 times x plus 2, x minus 4 times x plus 2. So to find zeros we have to equate it to 0. Then you will get x equal to 4, x equal to minus 2 you will get. So that I will write. So zeros of a polynomial. To find zeros, I have to equate p of x equal to 0. Here p of x is x minus 4 into x plus 2. So x equal to minus 4 I am getting from this factor. X equal to minus 2 I am getting from this factor. I have written these two. So zeros are minus 2 comma 4. So for this answer you will get 2 marks. So points representing zeros. Zeros occur when y equal to 0. When you will get zeros? When y coordinate is 0. So if you draw the graph, where the curve is intersecting the x-axis, that x coordinate is 0. For that x coordinate, y will be 0. On x-axis always y coordinate will be 0 only. So the points are minus 2 comma 0. This is the point on the x-axis where the curve intersecting the x-axis at minus 2 comma 0. So the given arch, for that if you draw the x-axis and if you draw the y-axis and if you locate the points, you are getting minus 2 comma 0. 1 point you are getting on x-axis. 4 comma 0 you are getting on x-axis. So these are the x-intercepts of the graph. So if you take, so the points are minus 2 comma 0, 4 comma 0. Already we got minus 2 is a 0, 4 is a 0. So directly you can write minus 2 comma 0 and 4 comma 0 are the x-intercepts of the graph. What are the x-intercepts of the graph? If you know the zeros, directly you can write minus 2 comma 0 is x-intercept where the curve intersecting the x-axis. That means minus 2 comma 0. Where the curve intersecting the x-axis, another point, that is 4 comma 0. 4 is a 0 here. So 4 comma 0 is a point where the curve intersecting the x-axis. For this you will get 2 marks. So alternative choice will be there for one question, right? So span. They asked to find span also. Span means here distance between two x-intercepts. Distance between two x-intercepts. Already we found x-intercepts. So those are zeros, right? Zeros. One zero I got 4, another 0 I got minus 2. So distance between these two, 4 and minus 2 on the x-axis. Distance between these two, distance between two x-intercepts, distance between two x-intercepts. So x1 is minus 2, 1 0 minus 2, another 0, x2 equal to 4. So span equal to 4 minus of minus 2. 4 minus of minus 2, you are getting distance between these two on x-axis. So at 0, 0 to 4, right side, this side, left side minus 2. So 4 minus of minus 2, so minus of minus you are getting 6. So 4 minus of minus 2, 6. So in between minus 2 and 4, how many are there? What is the length you are having? 6 units length you are having. So span is equal to 6. 6 feet. If they give in feet, you will write feet. So they asked to find intersection with the y-axis. With the y-axis also. They asked to find the intersection with y-axis. On y-axis always x0. On y-axis always x coordinate is 0. That's why in the given polynomial I am taking x0. So if I take x0, p of 0 is equal to minus of 0 square plus 2 times 0 plus 8. So in place of x I have taken 0. Then p of 0 is equal to 8. P of 0 is 8 means for x equal to 0, y. P of 0 is y. P of 0 is y coordinate. So for x equal to 0, I got P of 0 8. P of 0 means y value, y coordinate. For x equal to 0, I got y value 8. So 0 comma 8. This is the coordinate on the y axis where the curve intersecting the y axis. So at 0 comma 8, the given quadratic polynomial intersecting the y axis.